So we learned how dual algorithm by using ADFD finds a successor. And what is a successor? It's the metric of the elected root. Metric of the elected root. The lowest FD. You may have more than one path to a destination. Each path will have a FD value. The lowest of FD is the best path, is the successor path. And we also learned a very important point, the last point, how it elects a backup path. We call that backup path as a feasible successor path. For a path to be a backup path, by the way, the backup paths are only stored in the topology table. They will not be seen in the routing table. Now, for a path to be a backup path, it needs to satisfy a feasibility condition, which is there mentioned in that bracket in the last paragraph. What is feasibility condition? The advertised distance of the backup path needs to be less than the successor value. In another word, the advertised distance of the path that you want to be a backup path must be less than the metric of the successor route. So with the help of a nice diagram, we learned it. If you notice here, the advertised distance of this backup path is less than the successor value. This is less. So it is now placed into the topology table for the same prefix. This is a successor via router A, via router B, because it satisfies the feasibility condition. It is sitting here as a backup path, and only the successor route will be seen in the routing table. When the successor route goes down, this becomes the successor, and this will be promoted to the routing table. So all available paths will not be a possible path. All available paths to a destination won't be seen in the topology table. Only those paths that satisfies the feasibility condition can be seen. And in the routing table, only the best path. And now, there are two paths. Because the metrics are not same, we cannot do load balancing by default. EIGRP is the only protocol that supports unequal cost. You see, this cost is unequal. We learned that EIGRP is a protocol that supports unequal cost load balancing. But where is the unequal cost load balancing here? We don't have unequal cost load balancing because there is only one path with a lower metric is seen in the routing table. What do you understand from here? The unequal cost load balancing is supported in EIGRP but not enabled by default. We have to enable it by using a command called variance, which will be coming later. Question is, will EIGRP supports unequal cost load balancing by default? Answer should be no. Not by default. Needs to be enabled. Okay. Now the next fresh topic of the day here is the packet types in EIGRP. EIGRP has got 5 different packet types. When you are doing lab with Wireshark, you can easily capture and see them. Today I'll show you these 5 types of packets in packet tracer. When you learn like that, you will never forget. That's how it should be learned. We'll take just 2 routers, we'll enable EIGRP, and we will see these 5 different type of packets. The hello packets are sent every 5 seconds. With a hello only, the neighbors are discovered and established. Even after establishing neighbor, hello will be sent periodically every 5 seconds to maintain the neighbor, for which it is going to use 224.00.10. Whenever there is a change in the path, those changes are sent as the update by using the same multicast address 224.00.10. Now, when there is a query, when will there be a query? If a primary route goes down, and when there is no backup route, the routers will start querying whom? The other neighbors. And if the other neighbor knows the answer to the query, they send a reply. So the response to the query is what a reply is. And now for an update, query, and reply, there is always an acknowledgement sent. When a router sends an update, an acknowledgement is sent. When a router sends a query, whoever receives the query will send an acknowledgement. And when a router replies, an acknowledgement is sent. That's what you see here in this picture. You see the first router that is coming up is A. So router A says, my name is 10001. Who is there on the link? Inside the hello packet, you can see this. I'm going to show you by capturing a hello packet. I'll show you what is inside. You need to expect these things, what I'm saying. Router A will send its IP. This is the IP from where the packet is originating, the exit interface address. And now we'll take just 2 routers like this, 10001 and 10002, and we'll see this. And now B is sending its hello along with the update. B says, hello, hola, I'm B. I'm 10002. Here is my update. I got some update for you. So B is sending its complete routes from the routing table that B knows to A it sends. When the update is received, immediately an acknowledgement is sent. And then this update gets added to the topology table. After synchronizing the topology table with the incoming update, now A generates its own update and send it to B. And B now gets the update. Sorry, before that, B now immediately sends an acknowledgement to A. And B now gets the update, synchronizes its topology. And now the dual algorithm will take the best route in both the routers and put the best route into the topology, sorry, into the routing table. Right? These 6 steps happens for these 2 routers to get synchronized each other. So learning with Wireshark is the best. Any protocol you take, you should have a deep dive study for which Wireshark is the best tool. Wireshark is an approved sniffing tool. Usually sniffing tools are not allowed in the industry because people can sniff and see the data. But Wireshark is allowed. The reason is Wireshark will only capture data which are okay to capture. It won't be a security breach. An acceptable tool to capture what is going on in the network. It won't capture everything. It won't capture all layer 4, 5, 6, 7. It will never. It will only capture very basic necessary network information. Yes, I do agree when you do telnet, you will be able to capture the password using Wireshark. But why are you using telnet? You should not use telnet. When you use SSH, Wireshark cannot show the password. So Wireshark is an approved tool which we should always use while we study a protocol. Now, metric of EIGRP is 5 in number. Initially, the protocol was called as IGRP, Interior Gateway Routing Protocol. And this IGRP was a classful protocol. The classful protocols are not okay to use in today's network environment. We have everywhere subnetted classless. We have everywhere subnetted classless network. So using classful is a wrong idea. It's a bad idea, using a classful protocol. So EIGRP improved and made it as a classless is now called as EIGRP. So earlier version of EIGRP is Interior Gateway Routing Protocol. Because the enhancement is done, it is called as Enhanced Interior Gateway Routing Protocol. So right from the beginning, even during the IGRP days, we have this 5 metric. And it's the same 5 metric we still have for EIGRP, the improved version. But one difference is there. In IGRP, you have only 24-bit, whereas in EIGRP, you have 32-bit. That you can see here in the last page. Here you see. IGRP, in IGRP to calculate the metric, only 24-bit is used. In EIGRP, we have 32-bit. So 24, 32, how many more bits extra? How many more bit extra? 8. 8 to the power of 8 is what?
8.
56. That's why. If you are having an
256.
IGRP metric, how do you convert it to EIGRP? Just multiply by 256 because you got 8-bit more, you have to multiply. If IGRP metric is 100, EIGRP metric will be 25600.
256.
This is IGRP metric for the same route in EIGRP. It is 25600. What do you do if you want to know IGRP metric? You just divide this. by 256, you will get 100. So if you want to convert from, that is what in the last page it is explained. If you want to convert from IGRP to EIGRP, if you want to convert from IGRP to EIGRP, then you need to multiply. If you want to convert from EIGRP to IGRP, you need to divide the EIGRP metric. Because IGRP is only 24, so you need to divide. And EIGRP is 32, so you need to multiply. This is unnecessary discussion actually. Why? Nowadays, no one uses IGRP. You cannot even see IGRP in most of 99% of the routers today. If you will have then you can do something like this. Run all the EIGRP routers. If you're running in 200 autonomous system, run IGRP also the same 200 without redistributing. You no need to redistribute. Again, I'm telling you, you no need to redistribute. They automatically divide, multiply whatever is needed. For example, if IGRP is coming with metric of 1, it will automatically multiply and say 256. Yeah, automatically it multiplies. It has got backward compatibility with IGRP. That's what I want to say. Anyway, it's an unnecessary story, but once in a lifetime you need to know this, because if someone asks about this, you can talk. So the metric of EIGRP is using 32-bit for calculating the composite value. Now, this 5 metric are called as 5K values. 5K values. You see in the next page, everywhere in the formula, if you see, it is mentioned K, K, K. Yeah. So 5K values. But considered is not 5. Considered is only bandwidth and delay. These three are not considered. Why? This reliability and load are variables. You see, if someone is using the network, the load will be going high. If the load goes high, the reliability will go down. When someone stops using download, the load will go down and reliability will go high. So this is keep on fluctuating, going up and down and up and down. And if you consider this type of variable as a metric, if you consider this type of variable things as a metric, then EIGRP will keep on changing the path. When someone is using the network too much, then the EIGRP will say, no, this path is not good. Let's go to the next path. When that path is in use, then it will say, no, 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 that path is not good. Let's go to the previous path. It keeps on jumping when you consider variables. So they cancelled reliability and load, and they also cancelled MTU. MTU is not a variable one. MTU is the same like bandwidth and delay. MTU is a constant, same like bandwidth and delay. See, in a wire, the bandwidth is a constant one. 100 meg means it is always 100 meg. The load may go up and down in the wire, depending on the users. But the bandwidth of the wire is same always. In 100 meg, the delay is always constant. It won't go up or down. Likewise, MTU is also constant for the links. For various links, various MTU. But because we already have two constants, the MTU is not now considered. 5 K values of EIGRP, in which K1 is bandwidth. The sequence is very important. K2 is load. K3 is reliability. Sorry, delay, yeah, delay. Let me write it here. K1,
Sir, K3 is delay,
K2,
right?
K3, K4, K5. So this is the
Yeah, sure.
order. Yeah. See, K1 and K3 are considered.
K1 and K3 are 1 and the
If you
rest are
want to
0.
consider bandwidth, if bandwidth is 100, if I multiply by 0, what will happen? 0, which means no bandwidth. Instead of multiplying by 0, if you will multiply by 1, then it means you are considering. That's what Bala said. Bandwidth is 1, delay is 1, and others are 0. That's what you will see in the picture here, in the algorithm. K1 is 1, K3 is 1, all the rest are 0, which means they are not considered. Don't focus too much on these things. You need to focus on this red line. Metric of EIGRP is 2, K1 and K3. K1 is bandwidth. Which bandwidth? If you see here, this picture, to go from A to D, there are two paths. In the upper path, bandwidth is 1.5 meg, 1.5 meg, which is equal to 1500 K, 1500 K. Here you got only 64 K. Which one should I consider as a bandwidth? 1500 K, 1500 K, 64 K. In this path, which one I should consider? Slowest link bandwidth, which means you should consider only 64 as a bandwidth, the least bandwidth. Plus sum of delays, meaning what? 2000 plus 2000 plus 2000, 6000. So if you go via A, B, C, D, this upper path, the bandwidth is 64, delay is 6000. And then you take the bandwidth and then do all this thing, which is algorithm going to do. You don't need to do that. Like we take the delay 6000 and put it here and do it. And then find the best path. The lowest FD value will be the best path. In short, what I am saying here is the slowest link bandwidth plus sum of delay is the metric of EIGRP. Metric of EIGRP is slowest link bandwidth plus sum of delay. I already spoke on this page. And again, this is not an important page because there is no IGRP protocol anymore. Now, this another chapter called configuring EIGRP. How do you configure EIGRP? EIGRP is more flexible in configuring than RIP. RIP, if you want to deny a network for a subnet from getting advertised, you need to write a filter. Whereas in EIGRP, you don't need a filter, you have wildcard mask. Let's see. You see, EIGRP always works with autonomous system number. You need autonomous system number. Whether you have more groups or single group, you need to mention some number to the group. And this number, you are free to use any number between 1 to 65535. You can use any number from 1 to 65,65535. All right, you can use any number. And that number should be same on every router between which you want to exchange the route. Right. Now, the networks that you want to advertise using EIGRP, you need to use the network command and specify the network and mention the wildcard mask up to which the prefix need to be matched. For example, if you have a router here with 10.1.1.0, 10.1.2.0, 10.1.3.0/24/24/24. Now, if I want to run EIGRP only on this network, if I want to advertise only this network, easy. You can say network 10.1.2.0, 0.0.0.255. So the first 3 octet matches only here. So this will not be advertised, this will not be advertised, only this will be advertised. Only that will be advertised. Which is not possible in RIP because you don't have wildcard mask. Even if you say like this, it will take 10, not 10.1.2. So RIP will start advertising all 3. Wildcard mask is easy. Wildcard mask is good. Wildcard mask helps us to filter those networks that you do not want to advertise. Which means they want to advertise every network in that route. I'm telling you, if you do not want to advertise some network,
But most of the people don't use wildcard
out
mask,
of
na, sir.
out of
The
3
production
networks, I
network.
was advertising only one.
I mean,
Then I need wildcard mask. If I want to advertise all 3 of them, I'll simply say 10.0.0.0. You see, so wildcard mask is needed only for those people who have got policy
oh,
in what to advertise and what not to advertise. If you don't have policy, which means you want to advertise everything,
okay.
in such case you need not to use wildcard mask. Your network is like that. You no need. So you didn't put. It doesn't mean that no, everyone is doing that. No. I've seen many people using only wildcard mask always because they got policy in their company not to advertise for your networks.
Okay.
Okay. Now, see, there are 2 metrics in EIGRP. One is bandwidth, other one is delay. Now, bandwidth can be changed. For a fast Ethernet wire, 100 meg is the bandwidth. But if you say, no, I don't want to tell EIGRP 100. I want to reduce it. Then you can go to the interface and put this command bandwidth 50 meg. Even though the original bandwidth is 100, according to EIGRP, the bandwidth will be now considered as 50. 1000 kilobits. Because it's in kilobits, you need to write in kilobits. At multiply 1000 to the megabit. Same way, delay. Instead of bandwidth command, use the command delay. And then specify the delay value. So you can change the default bandwidth, default delay by using these commands, right? Now, when you're advertising EIGRP, when you're advertising, you need to advertise only those networks on that router. For example, in this router, I got two 10 networks, 10.4 and 10.1, and then two 172.16 network. So when I say 10 without wildcard mask, it matches in this two, and EIGRP runs in this two. And when I say 172.16 without wildcard mask, so it matches by default /16, and it runs on this two. You no need to mention about 192 because it's not in that A router, it is in some other router. That's what they have mentioned here. We know these things. I'm just covering this portion because it is told in this page. Now, using wildcard mask, I have already told you, in case if you do not want to advertise or run EIGRP on this link, then you use the wildcard mask to match only this to these two networks, .3 and .4, and this will not run EIGRP. You do not want to run EIGRP there because it's connecting to the internet. You do not want to advertise your internal network to internet. It is outside your EIGRP domain. External. So this is how the wildcard mask is useful in order to do filtering. I do not want to run EIGRP here, which means I do not want to send any EIGRP updates for safety. All right. Any questions so far? Okay. I'm going to take you to another topic, which is a little complicated, but you give a try. After I finish, you give a try if you have GNS3 or E in your network,
No, sir.
in your laptop, which is called default network. I'll definitely demonstrate this in our next class, but I want you to give a try. Take a screenshot of this before I teach. Take a screenshot now. You see, we got internet here, which is called as external AS, and this is your organization, and
Okay.
this is the edge router. Here they have shown only one router, which means router with a cloud, which means you got many routers here. Now, in your organization, if you do not want to learn the routes of Yahoo, Facebook, Google, what you used to learn is a default route. Do you agree? For all unknown destinations, we always use default route. Our own networks within an organization, we will use professed route. Using EIGRP, we'll advertise. But
Yeah.
for the internet, we will try to use default route. So this is another way of using default route. You see, this is your edge router, and this is your ISP network. That ISP network, you define it as a default network. You say to router A, if you don't know anything, just send your packet to this network. ISP will take care of it. You just send it to ISP. Okay. So using the default
Okay.
network command, you are defining which network is responsible for unknown destinations, unknown destination packet. Where it need to be sent, it need to be sent to ISP. Now, after defining it as a default network, you also need to have a static route in the router for that network. You may ask why? Why? That's a good question. Why? Because if the route is not seen in the routing table for this network, EIGRP cannot advertise it. If EIGRP need to advertise a network, that network need to be there in the routing table. Okay. For that sake, you wrote a static route and you have defined that network as a default network, and you are advertising that network also in EIGRP. Three things you are doing. One, you have EIGRP here. So you are advertising that network. But that network is not an ordinary network. That is a network which is defined as a default network. That's why you have a star. And that network, you have a static route to reach. That's why you have S. Now what EIGRP will do, because you are asking EIGRP to advertise a default network, it will advertise using D star. What is the advantage? Advantage is you no need to go to every single router in your organization telling which network is default. Dynamically, a default route is advertised using EIGRP to all the EIGRP fellow members. You see, it has reduced your work. Otherwise, you should have written a static default route on every single router inside the organization. Do you agree? Uh, D star means EIGRP given default network. So now, using EIGRP, all the routers inside your organization knows that I need to go to router A to go to unknown destination,
Yeah.
and router A will forward it to 172.31 because that is advertised, that is meant, that is configured as a default network, so the traffic goes out. All right, this is looking easy, but when you do it, there are some practical difficulty. I'll give you a clue. The difficulty will be because of the auto summarization that is there on EIGRP. Try and come tomorrow. We'll fix this tomorrow. Right? We'll